Yo, welcome back to REXTECH, where we spread the good news of the cloud. This is project number 2, right, with your boy. Last project, if you don't remember, check it out here. We sent ourselves live NBA scores to our email, right? Now, in today's project, we will create our own endpoint, our URL that you can search it, and it will bring you the updated schedule of NFL games, right? So we're in January, so you know we're going to the playoffs. So this is a pretty cool project that we're going to be doing. Now, for the solution and the services we will be using, containers, load balancer, and also API gateway, right? Now, these buzzwords of containers, API gateway, don't worry about that. I'm going to explain it to you. All right, so first of all, what the heck is a container? I'm not gonna get too much in the nitty gritty, but think of a container as, let's say there's a party, right? And the host is like, everybody has to bring their own stuff, but everything has to be in a cooler, right? You bring your own cooler, you have your own snacks, your own drinks, your own everything you need to have a good time at that party, okay? It's self-sustained, self-sufficient in that cooler. All right, so you don't have to rely on the host's freezer or fridge or their drinks, whatever. You have your own stuff, but it's stored inside a cooler. Now, that is the same thing as a container. A container operates the same, okay? A container hosts your applications, right? So in our situation, we're going to be hosting a Python Flask app, all right? So we're going to have a container, right? And this container is going to have all the libraries, all the dependencies, all the code to run your application. It's going to be self-sustained in this environment, right? Everything that is needed to run it is in this environment. So this makes it very lightweight, very portable, and you can move it from one place to another and still have all you need to run the application from one system, from one environment to another. You're just moving it back and forth. Everything you need to run the application is still there. Everything you need to have a good time at the party is still there. Whether you move from one party to another, you still have your cooler with all your self-sustained drinks, snacks, whatever you need to have a good time. All right, so this is our container, and it's going to have our Flask app that's going to be written in Python, right? So Python, whatever, and it's going to have all the dependencies and libraries and everything. So this is dependencies, libraries, whatever, to run the application for us. On AWS, there is a specific service called ECS, Elastic Container Service, right? This makes it easier for us to manage containers on AWS, all right? So we have ECS is going to be managing this container, okay? So what is the Flask app going to be doing? The Flask app is actually just going to be requesting data from some external API. All right, and then in the back end of the API, we don't really care about that, right? We don't really know or care about this is exposed to us. This is a third-party API. Last time we used sportsdata.io. We're not going to be using that. I'll show you what we're going to be using. But this third-party API is exposed to us, all right? So, boom. And also, if you don't know what an API is, check this video again to explain what that is. We have this API that our application is requesting information from to get the NFL schedule. All right, and then it's going to respond back with the NFL schedule, and it's going to be in a JSON format again, and then we're going to have to formulate it and make it into human readable form inside here, inside the container, okay? We're actually going to have more than one containers. We want 2 containers. So we're going to erase this. I'm going to make this bigger. 2 containers, right? And both I'm going to have the code and dependencies. So we have 2 containers here that is requesting information from this third-party API and is getting it back. So what is it doing with this information, right? Well, we're creating a system where we can actually retrieve the NFL games. Well, why do we have 2? Well, we have 2 for high availability. In case this container goes down, we still have another one able to serve us the content that we need for the NFL schedule. And so let's just say, hey, our solution becomes very popular, and then it moves from 10 people wanted to use it to get the NFL schedule to 1,000 people wanted to use it, right? Now, with that burst of increase, that could actually overwhelm our system, our containers, and cause them to terminate, cause them to die, cause them to slow down. The performance will be degraded because it's too much load, right? So what do we need? We need something called a load balancer. Now, I'm gonna have you take like 5 seconds to just think of what a load balancer would do in this case when we have a bunch of request traffic that is increased. What would a load balancer do? Just think of the word load balancer. I'm giving you 5 seconds. 3, 4, 5. All right, so what does the load balancer do? The load balancer distributes load. It's going to balance load, and it sits in front of these two containers. And what is it doing? It's going to distribute the load equally to these two containers. All right, so to make sure that one container is not overloaded with a lot of traffic and this one is just here sitting idle. So we're gonna have this huge load balancer here, and it's gonna be taking requests. Let's say this load balancer is going to distribute 50% on one side and 50% on the other side, right? Because equally, right? So if it's 100%, we're gonna put 50% load on this, 50% load on this. So let's say we have 1,000 requests coming in. Let's just say, right? How much is gonna go to this and how much is gonna go to this? 500, all right? So boom, 500 requests go there, 500 requests go there. This is just for simplicity so you can understand what's going on. So it's equally distributing the load that is coming in from people requesting information for the NFL schedule, but it's going to distribute it equally to the containers, all right? So that is what a load balancer is. On AWS, we be using a application load balancer, ALB, all right? So that is what this ALB will be doing. And the ALB on AWS automatically can take a bunch of load, right? Whether it's 1,000 or whatever, it can absorb it. That's the type of technology it is. It is made to absorb all that load and then distribute it to the back-end system. So we have these containers, right, doing the same thing. So this is gonna send traffic to this. This is going to request information for the NFL games from this API. Is going to come back. It's going to transform it. It's going to send it back to the ALB and then respond to whoever requested the information. And the same thing is happening here. So you have a copy of the same operations happening, right? But we're distributing the load between these two containers. Now, let's just say we want to add more security. We want to be able to throttle. Throttle is if one person keeps trying to get so much information at the same time, we want to be able to stop them like, hey, slow down, you're going too fast. You want too much information at one time. Also increase security, right? Make people have to use some type of authorization or API key to be able to request information from here. The ALB would not be the best solution for people to directly request from. Right? So now there's a specific service on AWS called the API Gateway that you can create an API endpoint for yourself. Just like how we're requesting from this API endpoint, we're going to create our own where people can request from. And API Gateway allows us to add security, add authorization, throttling, all those different mechanisms that we can use on the API. I won't get too much into it, but we're going to see how that's going to work. So now the requests will not be directly going to the ALB anymore, okay? What's going to be sitting in front of this is going to be an API that we create using API Gateway, all right? This is API Gateway service on AWS. We're going to create our own API, and we're going to call this, I don't know, sports data, right? And then users will be requesting, right? A user, it's a person. They will be requesting this API, and this API will be responding back to the user. Behind this API that we created using API Gateway, this is going to send to this and this back. It's going to be distributed equally amongst the containers. The containers, same application on each Python Flask app. It's going to be requesting from this third-party API that's going to give us information on NFL games, but it's going to come in as a JSON format. It's going to come in here. We're going to transform it and respond back to the ALB and travel all the way back to the user. This is the solution that we are creating. Now, you don't necessarily need the API Gateway just to get some hands-on experience and exposure to containers or ALB, but this is just something else, right? We've been working with APIs for a while, and we've been requesting from third-party APIs. But I'm trying to show you how we can create our own API, right? So people will be requesting this from some URL or whatever, right? Just like how we did over there, and then it's going to respond back to them. But they don't know, they're not going to know all of this. They're not going to know what the heck is happening here. The same way how when we request from this third-party API, we don't know what's happening in the background, right? They could be using the same system. We don't know. It's not exposed to us. The only thing that's exposed to us is the front of the API. Over here, the only thing that's going to be exposed to users is the front of our API that we create. Once they request, the only thing they're going to see is this and this. And once they get it back, they're going to see the NFL schedule games. All right, so yeah, that's what we'll be building today. I'll actually be, going to the computer and showing you a better drawn diagram that you actually see what the heck is going on, not all this gibberish. Then we're gonna actually show you the step-by-step on how we can build this on AWS. All right, let's get to it. All right, so we're gonna start from the right. So we already know the sports API, how that works based off of our previous project, right? We have the sports API and it's making requests on our behalf to the backend, which we do not know or really care about. This is what is being exposed to us. So what we have is actually, we will be using a Flask app. Okay, we'll be creating a Flask app. And this provides the logic that is going to query the sports API and format the data, right? And that Flask app will be in this box thing, right? You may be asking, okay, what the heck is a Flask app, right? Well, Flask is a lightweight Python framework, web framework that's used to build web applications and REST APIs, right? So in this project, we'll be using Flask to create a simple API that would query the sports data endpoint for us, right? Then the Flask app will be deployed or created in this box thing called a container. Container allows us to be able to package applications and all the dependencies, everything that is needed to run that application and be able to use it consistently across different environments, right? So we package it and put it inside this lightweight box called a container. All right, so everything that allows the app to run will be isolated in this. Now, Docker is the tool that we'll be using, right? Docker is what we use to build, manage, and run these containers, right? So it allows us to define our Flask app along with all the dependencies in something called a Docker file. And that Docker file will turn into the container image, and then we can use that to deploy anywhere. Okay, so ECS, Elastic Container Service, runs the containerized Flask app in a scalable and serverless environment using Fargate. Fargate is the serverless compute for containers, right? For ECS, Elastic Container Service. Then, as we can see, application load balancer, the traffic that is coming to the application load balancer, it disperses it across the endpoints that we have here, or the different targets. And we have these two ECS containers that will be our targets, right? So we're distributing the traffic across these two containers. Okay, so this makes it highly available, redundant, and if this container was to go down, we still have this container that's able to serve. All right, so that's the application load balancer. Now, behind the application load balancer, we have API gateway. So API gateway is a service that we're using to expose the Flask app's REST API, right, to users. So we created this endpoint here, this sports API, using the API gateway, and then users are going to send requests to the sports API that we created to get data and information of the games. And once you get that request is going to be sent to the application load balancer. The application load balancer is going to distribute the traffic of those queries between these two containers. It's going to hit one or the other or whatever. And then the app, the Flask app that is running on this container, would be able to make the request on our behalf, and then we get that information back, and then it just goes all the way back to the user. So question may be, okay, why doesn't the user just automatically just bypass all of this and just directly query the sports data like we did last time using Lambda functions? Well, the data is not organized, right? It's just raw JSON object that is coming. What we can do in our Flask app is organize it in a way that once it reaches the user, it's not a JSON object that has a bunch of gibberish in it. What it would have is we can format it to have the different games, the names of the teams that are actually playing, just like we did in the last project. And then we can send that to the user in a organized way in which they can use the information, right? So that's what we're going to be doing. And really, we're just doing this so we could get more experience and practice with containers, containerizing applications, understanding application load balancer, understanding APIs, how to create your own API, understanding how to use Elastic Container Service, right? So that is what we'll be building today, and let's get to it. All right, so we are in this local folder which I created called Containerized Sports API. This is where we'll actually be cloning the Git repo into. All right, and then at the top here is where I also have some commands which will be running for us to get situated. First of all, we're going to run the git clone. We're going to clone the repository into this local folder. Hit enter, and now we're going to cd. We're going to enter inside the containerized sports API folder, which we just cloned. Okay, next we need to create a repository in ECR. ECR stands for Elastic Container Registry. So this is the place where we're going to be storing our images, right? So we're going to copy this and we're going to paste it here. And this is saying create a repository with the name Sports API, and we're doing it in US East 1 region. Enter. All right. Now that repository has been created. We can actually go and check it out in our management console. We go to container registry and we can see Sports API here. So we've created that registry using the AWS CLI from our local system. Next, we are going to run this command, right? So this is for authentication, right? This command retrieves the temporary authentication token from ECR, right? So this is uses for us to log into the ECR, right? So that's what we're doing. And then we need to change this to our account ID, our actual account ID. We can get that from the AWS Management Console. We're going to copy and replace this actually. So let's go and get that ID now. Copy this. And we're going to change that here. All right. We're also going to change it in the other commands that we'll be preceding. I'm just going to go ahead and change that right now. Okay. So this is allowing us to get authentication to our ECR. So when we enter this, it should successfully log in. It says log in succeeded. All right. Let me clear the screen. Now we need to build our image. All right. So what do we build? Docker image based on Docker file in our project. So where's the Docker file? What is a Docker file? All right, let's check it out here. When we downloaded the files from our repository, we have here Docker file app. We're going to open all these files that would be relevant, which we will talk about. Close this. All right, so what is the Docker file? All right, let's see what's inside here. All right, so this is the Docker file. This basically tells Docker, the command which we're running, how we want to build our image, right? Let's check out the other files that is in here. When we type ls, we see all these files here. We actually already viewed it, but we're opening the ones that are relevant. So what is actually happening here? Here we have from Python, blah, blah, blah. This specifies the base image to use for the container, right? So it's a lightweight version of Python. And then we can move down to the work directory. Right, the work directory app, this basically, this sets the working directory inside the container. So all subsequent commands will run relatively to this directory that we have here. Right, so this is needed so all the files are organized in a specific directory structure within when it is being built, when it's being created. Right. Okay. Now we can move to copy the requirement. So what does this do? This copies the requirement tx file from the local machine that we have here to the container/app. Next, we are in the pip install. This is going to install all the dependencies from the requirement.txt file. All right. Then we're going to copy all files from our current directory into the container. Okay. So this ensures that the application code and all additional files are available inside the container. All right. Then we're going to move on and we're going to expose 8080. Right. So this basically informs Docker that the container is going to listen for requests on port 8080. CMD, Python app that is going on here. So this basically specifies the default command to run when the container starts. So in this case, it's starting our Flask app by running app.py with Python. Right, so this automates the process of running the Flask app for us whenever the container is launched. Let's see what's happening in our app.py file. Let's put this down a little bit. So we're importing some libraries here. We have Flask, we're importing that we're using Flask and JSONify. So Flask is the framework we're using for building APIs. JSONify helps us to convert Python dictionaries to JSON when we're responding. Request is so we can make request. HTTP request OS is so we can have access to our environment variables, right? So we've seen this before. We have the URL of our API, right? This is the endpoint that we're using, Sir Papi, whatever you call it. And then we have sports API key, which is our environment variable that we be getting our API key from, right? Because we don't want to hard code that inside our Python file here, okay? And then obviously up here, we are making an instance of the Flask app. And then over here, we are now defining the route. The route is going to be /sports that responds to the HTTP GET request. So the request is going to be routed to this function get NFL schedule, right? Because we wanted to get the schedule. Okay, so here we set the dictionary of the query parameters that we're using for the API request, engine, queue, NFL schedule, API key, which we got from up here, right? Okay, now response. So now here we're actually sending the get request to the SERP API URL, and we're passing in those parameters, right? So when it responds, we're storing it in this thing called data. Then from that data, what we are doing, we are extracting the games from the sports results, and we are looking for games, right? So we're then storing that inside games. And then if there's no games, we're just gonna print a message that says no NFL schedule available, blah, blah, blah. But if there is, now we have to actually format the schedule into a JSON object, right? Because that's what we're going to be sending. But we're changing this up and making it very personal to how we want this to look. Okay, so here we're initiating an empty list to store the structured data. So we're iterating, through each game in the games list, right? So that's what we're doing here. Game in games list. So if we can't find information for teams, then it's an unknown. If we do, then the game info, what we're doing is we're constructing a dictionary for each game, including this information, right? Away team, home team, venue, date, time, blah, blah, blah. All right. And then we are appending that information into the game info. And this is what we're going to be changed into a JSON format using JSONify, and it returns it in a 200 status. All right. So if there's an exception, if there's an error, we have it return a 500 error, blah, 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 something happens. And then over here, this actually starts the Flask server. So, Flask uses a server to be able to serve this endpoint, right? So we have a host, basically says, hey, we're making this app accessible to any network interface, and we're using port 8080. So this specifies the port on which the server is going to listen for incoming request. So request is going to hit this, and it's going to hit the endpoint of /sports, and then it's going to enter inside this function. It's going to do what it needs to do, and then it's going to return a JSON object. And if there's an error, then it's going to send this out, and it's going to be running on this port, and it's a server on any host on any network interface. Okay, cool. So this is the build command, and this -- platform is basically specifying the architecture that's compatible with Fargate, AWS Fargate, and then we're naming the image that is being built sports-API. All right, the next one, what we're doing here is this command basically tags our local build Docker image, right? And with the URI of the ECR. So the ECR requires a specific format to identify the image. So tagging the image with this URI tells Docker where to upload the image when we push it. So we've created our repository, right? We've logged in. Then I'm going to build the image. We just built it. All right. Then now we need to tag it. So we're going to run this command and tag the image. Okay. Then we need to push the image to the repository in ECR. So I click enter on this, and then it is pushing. Push, push, push. All right. So we've pushed our image to our ECR repository. So if we go to AWS and we check out the repository which we created, if we go inside it, we see the sports API latest image, which we just created and uploaded. Yes, sir. Got the requirements.txt file. This just shows the Flask and request library versions to be used in the app.py file. Okay, cool. Now let's go into AWS console. This is our image. Now let's check out the repository. Now we need to go to ECS, the actual container service, and we need to create a cluster. What is a cluster? A cluster is the building, the infrastructure that our containers will be hosted on. All right, so we need to create a cluster. All right, we're going to name the cluster. I already have a name here, Sports API Cluster. And we're gonna leave the default namespace. It's optional, but we're gonna leave it Sports API Cluster. And all of these also we're gonna leave default, and we're gonna create. So we're creating this cluster, all right? This is the infrastructure that is gonna host our container, all right? Let's check it out. Sports API Cluster. 0 services, there's no tasks. I'll tell you what tasks and services are in a bit. But the first thing we need to do is create a task definition. What is that? That is a single unit, a container that performs a specific job. We're going to create that, right? Now we're going to name this Sports API Task. Okay. So it's the smallest deployable unit in ECS and represents a single copy of a running container. All right, so these are some of the default requirements, some of the default configurations. We're going to scroll down. We're going to name our container. We're going to leave this task role as default. All right, we're going to go ahead and name the container Sports API Container. And we're going to get the image URI, right? Where are we going to get this image from? So we can go and open back up ECR, the registry, go to our repository, Sports API, and then we need to get the URI of our image. Okay, so we're going to copy that, and then we're going to paste that back here in the image URI, paste. And we're going to leave that as that. And then for container port, we're going to use 8080, right? Remember in the app.py, we decided to use 8080. That's the port that we're exposing, right? So we also need to do that here. Then we're going to scroll down, and this is where we put in our environment variables. Remember we did this in the last project. So we paste that inside a value, and then we continue. Next thing, leave this as default. Next things we need to do is scroll down, and we're going to create this task definition. All right, close this. All right, so our task definition, as we can look, this is our container name, and this is our container image. This is the URI, which we had pasted last time. So that's the image that our task will be using. Now let's go back to clusters, enter inside our cluster, and now we need to create a service. All right, so the service is the long running deployable mechanism, right? And this ensures that a specific number of tasks are running, right? And replaces them if they fail. So it handles scaling and all that stuff. So let's scroll down, leave all this default. We're using Fargate, right? Serverless. Scroll down. Select the task definition family that we created before, Sports API Task, version latest, and the service name, we're going to name it Sports API Service. And we're going to use service type as replica. And for desired tasks, we're going to use 2, right? Because we're going to put our application load balance in front of these containers that we'll be running. Okay, and the traffic will be split between those 2 using the application load balancer. Now for networking, we're going to leave these as default. We're going to spread it against many different subnets. And we're going to create a new security group. Leave the security group name as what is suggested here. Right now, we're just going to say all TCP. We're going to leave this open for this demo, for this project. I'm going to say anywhere, and we're just going to leave it like this. At the end, we'll delete all of this stuff, so just for the demo and demonstration purposes. For load balancer, now we are going to click application load balancer because we want the application load balancer to sit in front of our 2 containers which we configured. Okay, load balancer, we're going to name it Sports API-ALB, application load balancer. For these, we're going to leave as default port 80 for HTTP. And for target group, These are already inputted for us, so we don't have to change anything. We can scroll down. And then we are going to create. All right, now this is going to take a while because it has to create the application load balancer first, right? So if I go to the application load balancer first, we have to go to EC2 dashboard, and I go to application load balancer at the bottom here. We see that it is being provisioned, right? Provisioning. Sports API ALB is being provisioned. And we can click it and scroll down. We will see the DNS name, right? So this is actually what we can use to test if our containers are working. If through the ALB, we can actually be able to hit our containers and the app.py that is running in those containers that is also be making those requests. So from the application load balancer, it will be splitting the queries, the traffic between those two containers. So that is what we will be testing in a bit. Okay, so right now it's saying active, deployment and task, we have 0/2. All right, so we have 2/2 now. So we can go and test our ALB, right? Now let's go to our load balancer, application load balancer here. And this is our URL, right? So let's test this, right? We're supposed to be able to get the app that we have running on our containers, right? So let's check this out. You have to put /sports. Click enter. All right, so this is the JSON object that is coming from our containers, the application, right? The Flask application that we have running on our containers with the application load balancer that's fronting those two containers. This is what is being given to us. Now this looks like gibberish, but there's something here called pretty print. I'm not sure if only Chrome has it, but if I click pretty print, ooh, you get to see this JSON object here that has the games. So we have away game, chargers, date, blah, blah, blah. So this is live, right? This is like the games are coming up. So we see one today, tomorrow. We have one Monday, January 13th. So this is our JSON object. So we proved that it worked. We're able to hit that endpoint from our ALB, our application load balancer. So if I go back to this, scroll down, we can see. So from our load balancer DNS URL, we are able to hit one of these containers and the Flask app that is running on it, which is requesting information from that SERP API, right? And it's responding back with the information. We're transforming it here, and then we're just routing it back to the ALB, and that is how we are getting this. So this is where we are at right now. We need to build and expose our sports API using API gateway. Okay, this will be fronting the application load balancer. All right, so this is what we need to be building right now. So we're going to go to API gateway. And then we are going to create an API. All right. There's going to be a REST API. We're going to build this. And we're going to name this Sports API. Create. Now we need to create a resource, right? /sports. We want to name this /sports. This is the endpoint resource. Now we need to create a method under the sports resource. And it's going to be a get, right? This request is going to be HTTP request. Is going to be a get request. We're going to do HTTP proxy integration. And the method is going to be get. We're going to get the endpoint of the ALB. Start with http:// We're going to copy that, paste it here. Don't forget to put the /sports, okay? The /sports is the actual endpoint on the app.py application. Then we're going to create this method. All right. So we're going to deploy the API. And we're going to say new stage and deploy to dev. Okay, just development, right? Deploy. Now we want to test this API, right? We're going to invoke using the URL of our API, which we just created. API, we're going to do /sports for our resource and click enter. Woo! We are able to get it again. This is coming from our API URL. If I click the pretty print, woo, we see it.
So you just created your own API that other people can request information from, data from, and the data is NFL schedule, all right? And then they can manipulate it however they want, but you've just created your own. So that's pretty cool. That's pretty sick. Let's go back to this. This is what we just created. So we just did the sports API. We have the application load balancer. So it's routing all requests from this API to the application load balancer. The application load balancer would then distribute the request to two of these containers. Then the Flask app that is running on the containers will make the request to the SERP API, get the response back, transform it into a way that we want to be able to show the NFL schedules. Then it will be routed back to the application load balancer, back to the sports API, and then whoever requested it, it will go back to that client. So that's it.
Let's delete the sports API. Let's go and delete that. Copy, confirm, delete. Delete all these resources. Okay, next we need to go to our ALB and we need to delete the ALB, application load balancer. Copy, confirm, delete. Then we need to head to ECR and delete that repository that has our image. Delete that, don't need it anymore. Then we need to go to ECS. Okay, first things first, we're gonna delete our task definition. Click actions, actually deregister. All right, deregister the task definition. Then go to our cluster and we're gonna enter, click that. Then we're going to actually select it and we're going to update the service. Okay, and we're gonna move it from 2 to 0. Update, because remember we had 2 containers, now we're changing it to 0. So it's gonna update that to 0 task running. And then we can delete that service, delete, copy, paste, delete. All right, close that. Now we can actually delete our cluster. Cluster, delete sports API, cluster, copy, paste, and delete. And that is it. You should be cleaned up now.
All right, thanks for sticking around with your boy. You've made it to the end for this project. Hope you learned a thing or two. Now, for tomorrow's project, you'll be with Alicia doing some really cool, sick stuff. If you have any questions, check out the link in the description, join the Discord, and as always, make sure you keep sharing the good news of the cloud. Catch y'all later.